Hello and welcome to another video in this series of Java for Scientific Computing. In this video I'm going to talk about evaluating mathematical expressions when they are given as a string. In order to do that, I'll use first of all, this works. The library that I'm going to use for this purpose only works for real numbers, and again, real numbers are doubles, special numbers such as pi and e, minus square root of 2, and etc. Okay, any real number this works. And I'm going to use the expression for j library, and if you can just Google it and download it from internet, or if you're using Maven, for example, to build your project and manage your project, you can just simply go to search.maven.org and look for expression for j, and here's the Maven dependency. I put it here for you. So the group ID is net.objectHunter, and the artifact ID is x4j, and the latest version I believe is 0.4.8. okay, I'll show you how to, if you've never used Maven, I'll show you how to use this. Now here's how to use this expression for j library to evaluate strings which contain mathematical expressions. First, you have to define the expression as a string, and then you have to define the variables. Say, for example, this expression has the variables such as x, y. So you basically define a hash map with a string and a double value. So it's a map of variable and value pairs. So you set the variable value pairs in this map, and then you evaluate the expression using the functionalities that are built into this expression for j project. Now if you go and look at my look at the GitHub repository that I introduced a few videos ago, I have a math utils class, and in that class I have two methods, two static methods, evaluate. One of them takes a string and a map of a string double pair. Okay, so you can define a string which contains an expression of multiple variables and put the values of each variable into this map, and then this function just evaluates that. Now if your mathematical expression doesn't have any variable, it's just a pure math expression, for example something like your string is something like x 1.2 to the power of 3 times pi. This doesn't have any variables, so you can just use this method, evaluate this string, or use the first method and pass a null value, null object for the map. So if the map is null, it just assumes that it's a pure math expression with no variable. Okay, now how does the x4j works? If I want to show you how to actually create your expression and build it, so you define your expression as a string. Okay, so define the string expression, for example x squared minus sine of x times y. So we have two variables, x and y, some operators, power, times, minus, and some functions, predefined functions, sine for example. And then you define your map, a string double, I call it vars, define variable value map. And then you use the expression for j class called expression builder. So let's call it EB. So you create a new expression builder object and pass your expression to it. And in this expression builder, you set the variables. And in order to have the variables, you just can call the map and get all the keys in the map, because remember, the keys are strings, which are the names of the variables. Now obviously you cannot have you cannot pass an array list with the duplicate values for the variables, because variables have to be unique. So you pass a set. That's why we're passing a set, and this set can contain x and y. Okay, now that we defined which parts of this expression are our variables. The next thing is to define an expression, and in order to do that we just call the build method. So we tell the expression builder, these are my variables, and now you build it, and it returns an expression. Now that I have my expression, which now the expression knows which parameters in this expression are the variables, and then it also knows what the predefined functions are. For example, sine is a predefined function in the X4J project. Okay, so you now set the variables, basically the variables and the values. Now you, instead of passing the key set of the map, you pass the whole map, which contains the variables and their values. And finally, after you're setting the variables, you just evaluate the expression, and the result is just a double value. Okay, and the tip here is that you can chain all these lines together, and I'll show you an example of how to do that. So basically you can start with this double equals result, and you start with this new expression builder, and then after that you add a dot variables, you set the variables, and then after that you add the dot build, and after that you add the dot set variables, and eventually you add the dot evaluate. Alright, so how does it work actually? So we saw this expression. Let's consider this expression, x squared minus sine of x times y minus cosine of x over y. Now if you go into the expression for J archive, Java archive, it has 4 packages and a couple of top level classes, right? I already told you about these 2 main classes that we use, expression and expression builder. So you pass your expression first to expression builder, and then define which characters in this expression are your variables, and then the expression builder creates an expression, builds an expression based on the characters that are assumed to be variables. And it already has some functions built in, so it knows the some built-in functions. So you cannot just use any type of function. It has to be one of the functions that are defined in this expression for J library, and I'll show you which functions have been defined already. And so operators and functions are predefined. That's why we also have an operator package. So we have a function package that contains the predefined functions, and our operator package that contains predefined operators, minus, times, divide, division, the power, and some other operators that we'll look at. And then we have a package called tokenizer. So basically tokenizer takes your expression and creates some tokens. These tokens could be functions, variables, operators, and some numerical types. Okay, so tokens are basically the way that the class, the expression builder, understands how this expression has been created. Okay, what is the meaning of each character of the groups of characters. So once it knows the tokens, then it uses something called shunting yard algorithm. So basically, after knowing what is what in this expression, it has to know how to evaluate them, because when you're dealing with mathematical expressions, some operations have precedence over other operations. For example, in this expression, I cannot evaluate minus before evaluating the power of 2, for example. Okay, so the power of 2 has precedence over minus. And then the other thing is that the general precedence is from left to right, right? So shunting yard also tries to start from left to right and figure out what these precedences are for the operations. So as I mentioned, the tokens are variables, functions, operators, and some numeric types. Okay, we start with tokens, applies the shunting yard, figures out the order of evaluations, and then you pass a map of the values for these variables, and then it eventually figures out the value. Okay. Again, it works based on the shunting yard algorithm, and this is from Wikipedia. If you just search for shunting yard algorithm in Wikipedia, it takes you to this web page, and basically it says that in computer science, the shunting yard algorithm is a method for parsing mathematical expressions specified in infix notation. Now, I've already told you about the parsing, the meaning of parsing. I told you that in the number classes, such as double, integer, there are already built-in parsing methods for just strings that contain a single value for a double or an integer. Okay, but now this project X4J basically extends that to any mathematical expression. So you can produce either a postfix notation string, also known as reverse Polish notation, RPN, or an abstract syntax tree, AST. The algorithm was invented by someone and named the shunting yard algorithm because its operation resembles that of a railroad shunting yard. And the shunting yard algorithm was later generalized into operator precedence parsing. So this you can just click on operator precedence parsing, and it takes you to another Wikipedia and gives you more information. Okay, so this is the basic idea of shunting yard and evaluating expressions. Let's head to Eclipse. So in the GitHub math library, there is a if you look at the reference libraries, I've already included the expression for J. Java archive, it's 0.4.7, but let's say you want to use Maven. So I am going to create a Maven project here. Let's create a simple Maven project. Let's call it demo expression artifact demo X, for example, and then finish. Now we have our Maven project. And in this project, let's just create a simple demo, and we want to have a main method to just evaluate some expression. Okay, string, my string is let's call it x2 minus sine of x times y plus cosine of x over y. Okay, this is the expression given as a string, and then I create a map, string double vars new hash map. Okay, and also need to import the map from Java util, and let's do the hash map again. And it already infers the types, so we don't need to write them. In the vars, I put a string, which is x, one of my variables, and let's put a value of 1.2. Vars put y, let's put 3. Okay, and it's complaining because it's expecting a double, and by default 3 is a integer, so 3.0. Okay, now I need to add the expression for J library or Java archive to my project, and the way I do it is using the POM file, project object model, and you can just go to dependencies, add dependency X4J, object hunter, this one, and the latest version is 0.4.8. Now that we have it, you save it. Maven already downloads it, inputs it in the repository, your local repository. Okay, now that X4J is on the build path, let's create an expression builder. EB new expression builder, and we pass our string s, okay, and then eb set variables, eb just we can add variables s dot get vars dot key set, or we can just add them manually, y, x and y. So we set the variables and then we define an expression. Let's import it, expression let's call it e, for example, or ex eb dot build. When you build it, it returns an expression, and then we need to set the values, basically set variables, and it can take a map of a string double vars, okay. And finally, let's get the result, expression evaluate, and let's print it, system.out.println result, and let's run it. Minus 4.35. Let's just say it's pi, something numeric. Then what happens? It returns pi. It doesn't care. So you can set variables. If it cannot find variables in the string, that's fine. It just evaluates it to whatever it needs to be evaluated. So there's no problem with that. But in cleaner syntax is something like this. Double result. Let's hide all of this. New expression builder. We set the s. We create this, and then variables. This time I'm going to use the map that we created, and from the vars I get the key set, okay. Still complaining about the type mismatch. So we set the variables, and when you do that, then what happens is we build it, okay, and after we build it, we set variables and pass in the values. Basically, we set the variables, basically set the values of the variable using the variable map, the vars map. And once we set the variables and their values, we just evaluate it, okay? And then again, we can print the result. (3.141565), okay? Now the third way, which I already told you, you can use my mathlib class, which is called mathutils, and it is in the util package here, mathutils. I have two methods called evaluate and evaluate. One takes only an expression and it assumes that it doesn't have any variables. It's pure mathematical expression with no variables, so it just builds it and evaluates it. If you pass in a string double map, it assumes that, first of all, it checks whether or not it's null. If it's null, so it calls the previous evaluate function. So it assumes that there is no variable. It's just a pure numeric expression. If the map is not null, it goes through the routines of creating the expression builder, setting the names of the variables in the expression builder, and then it builds it and returns the expression, and then you set the values of these variables, and finally you evaluate that, okay? Now, in order to add the dependency on this project, on our project, we can go to build path, configure build path, and add the mathlib dependency. Okay. And after we do that, I'm going to just say double result equals math utils dot evaluate. My expression is s, and then my variables and values are the vars map system.out.println result. Okay, it still works. Now, because this expression here, the s doesn't have any variable, I can just pass in null to this method and it still works. Okay. Let's put some values, x to the power of 3. Okay, and what happens if I pass in null here? Now it complains. The tokenizer complains that there is a token here x that I don't know what to do with it, because you didn't tell me whether or not, what kind of token is it? Is it a variable? Is it something else? Unknown function or variable x. So the tokenizer first looks at the expression, and based on the information that you provide, which is a map of which characters or the strings in your expression are actually your variables. So if I pass in the var now the tokenizer understands that x is a variable. This character is already a predefined operator, and 3 is just a number. So tokenizer has no problem, and we will get the result. Okay. Now your variables don't need to just have one letter, one character. They could have multiple characters, and it still works. Okay. Now let's finally look at the inside of the expression for j. So as I mentioned, there are 4 packages here, and 2 main classes here. One is expression builder, and one is expression. So let's start with operators, and I'm going to decompile this operator class. One is operator, the other one is operators. And these are all the operators that are predefined: plus, minus, times, division, percentile, this power, exclamation mark, hash mark, $sign, and semicolon, colon, tilde, less than, greater than, this symbol, and equal. These are allowed operator chars. Okay, and operators has to only be one character. And then in the operators class, it basically gives these operators some index, and these indexes, I assume, are going to be used in figuring out the operator precedence in the expression. Okay, that's why it gives them index. In the functions class, again, we have a function that has some methods, and then some functions. And these are the predefined functions: sine, cosine, tangent, cotangent, log, log1p, absolute value, arc cosine, arc sine, arc tang, cubic root, ceil, floor, sine hyperbolic, square root, tangent hyperbolic, cosine hyperbolic, power, x, xm1, log 10, log 2, and sgn, which is the sinum or the sine function. Okay. Now, in order to use these, let's create sgn of 3, and let's run this. Now it doesn't know sgn because the spelling is wrong, so we use sign, sign. It still doesn't know what sign is. Let's use abs, for example. 3, abs of -3, 3. Notice I'm passing in the vars, but it doesn't care because it cannot find it. If it cannot find these variables in this expression, it's fine. And we can try other functions, for example sqrt of 3 or 4, for example, which is 2 of 2 should be 1.4 something. Yeah, so square root 4 works. Let's try power, for example, power of 2 to the power of 3, still 8. Okay, so power works. And you can try other things, for example like 10 of 2 should be 0.3, and then let's multiply this by like 10 of or add it like 10 of 5, and we know that this is equal to like 10 of 2 times 5, which is 10. So this should return 1. Yes. So you can use all these functions, and let's see what is the actual literal for the sign. Signum. Okay, I was using SIGN. We have to use SIGNUM. So signum of -1, it should minus 1.2. It should return -1. So sign function returns either -1, 1, or I assume it returns 0 for 0. Yes. 1.3. Okay, 1. Yeah. Alright, this is the expression builder. If you're using Maven, you can always get this library from Maven Central. It's very easy to use. Let's go back to here and recap one more time. So you start with your expression. You have to create the expression builder and pass it to the expression builder. Internally, expression builder runs a tokenizer to first of all digest what is what in this expression. Okay, and in order to do that, you have to tell the software or tell Java what characters or what strings in your expression are your actual variables, right? For that, you have to use your expression builder object and set the variables, and then based on that and the predefined functions and operators, you can build the expression, call the build method in the expression builder, and eventually you get an expression. Now this expression has been fully tokenized. The only thing remains is the precedence of the operations, which operation is first, and that is internally done in the expression object using the shunting yard algorithm, right? So finally in the expression, you set the variables of these, set the values of the variables. And I find it very easy to just in the beginning define a map of the string double pairs and then use that to build the expression and set the values, and finally you evaluate your expression. Okay, that was very simple. Thank you very much for watching this video, and please like and subscribe. I'll see you next time. Hello and welcome to another video on my channel. In this video I'm going to continue discussing the expression evaluation topic in Java, and if you recall, the library that I'm using for expression evaluation is X4J. And to briefly recap about what I talked about in the last video, I mentioned that the way this works is you define an expression as a string, and then you define which parts of this string are actually your variables, right? So variables are defined by the user. There are some built-in functions and operators. So we said that the operators and functions are built in, okay? Like sine, cosine, operators are times, raising to some power, and division, and etc. Okay? And we said that the way this library works is it based on the input that the user provides, it breaks down the expression into some tokens and passes it to a shunting yard algorithm, which determines how to evaluate the expression. Basically, it finds the order of evaluation and determines the operator precedence. Okay, that's why we have a tokenizer package. So there are four main packages here: function, operator, shunting yard, and tokenizer. And the two main classes are expression builder, that is where the user specifies the name of variables and then builds the expression to create the tokens, and then the expression actually runs the shunting yard algorithm. But then now the question is that I mentioned that the operators and functions are predefined. So the question is, what if I want to also implement my own function? For example, I define a function and call it myfunc, and it's a function of x, for example. And now let's say I have a string expression as x plus myfunc of x, and I want to just be able to evaluate this based on the implementation that I have for my func function. Okay, so how do I do that? Now the way you do it is by extending this function class. Now we'll look into this function class, but this function class is not final. It has some final fields, but it's not final, which means you can actually extend it and implement your own version of the function. So here's an example which I call it the custom function. And this custom function basically extends the function, which means it's a subclass or subtype of function, okay? And when you do that, you have to override the constructor, because there is a field called name, which is the name of the function. In this example, it's going to be myfunc, and it has to pass it to the super constructor or super object, which is the function. Function is the super class, custom function is the subclass, okay? And also it needs to override one particular method, which you probably can guess which method it is. It's the method that you have to define the mathematics of this custom function. Here, let's say I'm defining this as the argument to the power of 2. Now the beauty of this type of implementation, which is called a vararg implementation, vararg, variable argument. Now the beauty of this is that you can have you can either have one input or multiple inputs, okay? So your function can be a function of single variable or multiple variables, and this array of args are basically is the array of your arguments. Here I'm assuming it's just a function of one variable, so therefore I'm assuming that this variable, this args has one component, one element, which is arg0 at index 0. And this custom function is basically taking this argument and raising it to the power of 2. It's a very simple thing, okay? And then when you go through the routine of building your expression and evaluating that, what you need to do, you need to define an object of type custom function and give it the name. So you set the name in the constructor, and this name will be final, which means after you define it in the constructor and the final field, which is the name, is initialized, you cannot change it again, okay? There is no set method for changing the name, because it's a final field. It can only be assigned during the initialization, and that happens through this direct call to the super constructor, okay? And so I define this. So the name of the function is given in the constructor, and the mathematics of the function is already defined in the class when we implemented this object, okay? Now let's say I start with the string s, which is x plus myfunc of x, okay? Previously we only had predefined functions like sine, cosine, whatever, and now I have my own defined function, myfunc, okay? And now the routine is that we start with the expression builder, pass our expression to this, and then set the name of the variables, tell Java which parameters, which parts of this expression are actually our variables, which is x. But then we also call another method, which is functions or function. I mean, if you have multiple functions, you can call the functions method, and it takes a vararg input, which means it can have multiple inputs. You can have multiple custom defined functions. Here I only have one. Okay, so not only I tell the Java which parts of the expression are my variables, I'm also telling it my custom defined functions. Okay, and now the expression builder knows everything else. It knows the operators, or it assumes that all the operators are the ones that are predefined. Okay, and now this my underscore func is also something defined for the expression builder. When it runs or calls the tokenizer, it creates a token for this expression my func, and it knows that it's a type of function. Okay, and then it looks into this apply method to see how to evaluate that. So tokenizer has no problem here. And then the expression, and again we can set the value of this variable x, and everything will work. So let's head to Eclipse and test this. Now let's first look at the expression builder and the function. As I mentioned, so in the function, first of all, function class is an abstract class. Okay, and which means it can have actually abstract methods or abstract fields, and the reason it's been defined as an abstract method is because it has this abstract method called apply. So in order to force the user to implement the apply method every time they extend this class, they had to define it as abstract. Okay, now as I mentioned, the name is a final field, which means, and it's protected, which means the only access that you have to it is through the subclasses. It's private with the exception of subclasses. It's the meaning of the protected. Okay, and in Eclipse there is this yellow diamond, which is has a little bit of hole inside of it, which means it's a field. Yellow diamond means it's private and it has the label of final. Okay, so we have two final fields and are protected number of arguments, because you can have more than one argument for this function. The function can depend on multiple arguments, and that's the beauty of implementing the apply method as an vararg input. Okay, so two protected final fields, two types of public constructors. Okay, circles are methods, and green is public, and it has the label of constructor, and two public methods, get name, get number of arguments. Note that there is no set name or set number of arguments, because these are finals, these are constants. Once you initialize them, you cannot change them. And there is an abstract apply method, which is public, and there is a deprecated method called, and it's static, called get allowed function characters. And the newer version of this function is the new one, this public static method, which is valid function name. So when you extend this class, you only care about this apply method, and it automatically forces you to have a call in your constructor to the superclass, which is basically this one. So you can either implement this or this one and specify the number of arguments. Okay, now this is our abstract class, and then here I already defined a custom function, and in the custom function I extend the function, and my custom function is not abstract, it's just a public regular class. And when you do this, it forces you to basically have a call to the super constructor and pass in the name. So the constructor has to at least have one parameter, which is the name, and it passes it to superclass. And basically what happens is that it assigns this it initializes these two final fields, okay, and then it also asks you to implement this abstract method apply with a vararg input. And right now my power of 2 raising to power of 2 is has only one argument. Okay, now in the function class demo, I create some function func1 of type custom function. Okay, I didn't need to have it as custom function, it could also be function. I believe it should work. Let's import it from the object hunter, and that's because this is polymorphism. So let me just write it down. Polymorphism. If you are not familiar with what polymorphism it is, it's basically states that every subclass can be assigned to a superclass. Okay, so every subclass is a type of its superclass, so you can have this kind of polymorphism. Okay, and then I define my string with variable x and an unknown expression, which is my func, and then it's not a built-in function, right? It's not the name of a built-in function. And then I define my expression builder, set the names of the variables. So tell Java, okay, x, this x, wherever you see this x, is my variable. Okay, but then I use this one too. So this is the new addition to the previous cases. So we also set the functions. Now if you look at we also, if we only have one function, I can just call the function. If you have a list of the functions, you can just call this method. Or if you have multiple functions and they're not in the format of a list, you just use the varargs method of type function. Okay, here I'm just calling functions, and I have one function, which is fine. Okay, and then we create the expression by calling the build method on the expression builder, and again it calls the tokenizer and goes through the expression and understands what is what. And now the tokenizer understands that, okay, my func is a predefined function and it already knows how to implement it. And then you set the value of the variable x, and then you call the evaluate method, and this should work. Yes, 6. So if you recall, my func was taking x and raising to the power of 2. So basically this is equivalent to x plus x squared. 2 to the power of 2, 4 plus 2 is equal to 6. Now if I comment this out, the tokenizer probably complains that it doesn't understand what my func is. It's a token unknown to the tokenizer. Unknown function or variable my func. Okay? So the tokenizer doesn't understand what it is. You have to tell it what it is, and we're telling it, okay, it's a function. Okay, so this is how you define your own function. Now exactly in the same way, another thing that you can do is, or another question that you can ask is, okay, what if I want to define my own operators? Maybe there is some symbols that I use for some sort of operator that is not predefined or not built in. So exactly in the same way, we have an operator class in the operator package, and you just basically extend it and create something called custom operator. And you have to define the symbol of this operator as a string, and number of operands that this operator operates on. For example, if it's sorry about the background noise. For example, if it's something like raising to some power, it operates on basically 2 operands. One is the base, the other one is the power. Okay, Is it left associative or not, and what is the precedence, and it directly calls the superclass. And then again it also has the apply. Now here, unlike function, the apply basically you have to tell it how to operate, how the operator is defined between the two operands. So if my number of operands is 2, basically args has 2 elements, arg0 and arg1, and you have to tell it how these are related to each other, how they interact with each other. For example, in Python, a star means power, the power operator. So if I say a star 2, it means a to the power of 2. Okay, so the symbol for my operator would be a star, and it operates on 2 operands. And the mathematical expression is take the first argument, arg0, and raise it to the power of args1. Okay, and this is example. Let's say op1, it's a custom operator, the symbol is star, 2 operands, and it's not left associative, right? And then the precedence, I just use one of the built-in precedences in the operator class, which is the power precedence. Okay, and then let's define the string as x star 5, and the routine expression builder, pass the expressions, tell it what symbols are the variables, and the new one is this one. Now I call the operator function or operator method in the expression builder, and tell it, okay, this symbol star is some sort of operator with these properties. Okay, then tokenizer understands that, okay, this is an operator, puts it in the operator stack. And then expression, you create an expression by building the expression builder and set the variable and evaluate. Okay, so let's head to Eclipse and look at it. I've already defined a custom operator which extends the operator, and it forces you to have a call to the super constructor, and also it forces you to override this apply method. So if we go here, if we go to the operator class, and it's an abstract because the override method is an abstract. So abstract classes can have non-abstract methods or constructors, that's totally fine, but they can also support abstract methods. And the feature of being abstract, the property is that it forces the subclasses to implement this. Now another way that some people normally use is that to make it a regular function, but then inside the a regular method, but then inside of it you just throw an exception saying that you have to implement the method. But that's not good because it just interrupts the program. It's better to just go with abstract and force the programmer to implement it. So my goal is to take the argument 0 and raise it to the power of argument 1. Okay, now let's go to the custom operator demo. I can also define it as an operator. It already understands this, and the import is already there because of polymorphism. Any custom operator is basically an operator. So the symbol is star, it takes 2 operands, it's not left associative, and the precedence is just the precedence of power. So if we go and look at this should have the highest precedence. The power has the highest precedence. Okay, and this is my expression x star 5, pass it to the expression builder, my variable is x. Now this is the new line that has been added, new line to define the operator, the new operator. Okay, now I'll tell the expression builder, when you call the tokenizer, tell it that star, this op1 star is basically an operator, and it has to go into the definition of the apply method in this class to see how to calculate the value of this operator. Okay, set the variable to 2 and then evaluate the result. So this should give me 32. Yes. Now let's say because of the precedence, if I put this 3 to the power of 5, 243, which is correct. 3 to the power of 2, 9. Okay, I hope this video was useful, and thank you for watching. Please comment, share and subscribe, and I'll see you in the next video. Hello and welcome to another video on my channel. In this video I am going to show you how to do a simple timing benchmarking on the expression evaluation package or the project that we were using for our expression evaluation purposes. And if you recall, we were using X4J Java library to do the evaluation, and the way it worked was that you define a function as a string and pass it to an expression builder, and it tokenizes that, and then you set the values of the variables, and then it finally evaluates the expression and returns the numeric value of the expression. Okay, now what we want to do in terms of time benchmarking is that we want to run the evaluation of a simple function, let's say just a sine function, and 1 million times. So let's say we want to evaluate it 1 million times, and let's say we want to evaluate for 1 million points inside the 0 to pi interval. Okay, and then we want to do the same evaluation but using the built-in math.sine function. Okay, instead of having the string sine of x, we want to use the math.sine function. And if you recall, this when we do this, it calls the native, it has a native method from the strict math class, which uses the native libraries from the operating system. Okay, now in order to calculate the time it takes for executing some lines of code, you can use the systems class, which is in the core Java libraries, and call the current time in milliseconds method. Okay, and this returns a long value, so the return type is long, and so it returns the current time in milliseconds. And then basically the way you can do it very simply, it's you create a start, this should be long, so you create a start variable of type long, system.currentTime millis, and then do your stuff, run the calculation or execution or whatever, and then get the, again call the current time millis and assign it to the variable end, for example, and the total time duration is basically end minus start, and then you can just print it, system.out.println duration in milliseconds. Okay, in milliseconds. Remember, we're calling the time in milliseconds. Now, in order to save the hassle, in my Git repository, the mathlib, in the util package, I basically put all this code inside a simple timer class. Okay, so you create a timer object, new timer, and you call the start method, and basically what it does, it calls the system.currentTime mills, and basically assigns it to a variable which is basically the start variable inside this class. Okay, and then you do your stuff and call the stop method, and what the stop method in the timer does, it calls the system.currentTime millis again and assigns it to the end field or end variable inside the timer class. And then you can just do a system.out.println on the timer object. What it does is, whenever you do this, try to convert an object into string, it calls the toString method in the object class. If you have not overridden that, it just calls it from the object class. But I've already overridden this this toString method in the timer class, and it basically does the same thing, duration n minus start. So it basically returns this evaluation. Okay, So let's head to Eclipse and see how we can do this. Alright, so this is our demo expression library. If you recall, we are using Maven for dependency management, and I've already added the expression for J library in the Maven dependencies. And if you look at the POM file, project object model, in the dependencies the expression for J is there. It's using the 0.4.8 version of this. And if we go to the demo X, let's create a simple class called simple benchmarking, and we want to have a main method. Okay, and the main method, what I need to do is first create my points, 1 million points, and I'm going to use an array x vals. These are my vals and x values. Okay, and I want to create a uniform distribution of these points across the 0 to pi interval. So in my math util, mathlib, if you go to the util, I have a math utils class, and it has a linspace method which returns an array of doubles, and it's a static method. Okay, and you specify the start, the end, and either the number of points and the steps between points. Now if you go with the number of points, basically it creates a uniform spacing. And the same thing, if you, instead of specifying the number of points, if you specify the step size, it creates incremental steps. It's uniform, but it checks when you reach the end point. Okay, so basically when you use this method, start, end, and number of points, the start and end are always included. But when you use start, end, and the step size, it starts with the start point and adds the step size until it reaches exactly at the end or before end. So end might not be included. Okay, that's why I have this. So I start with the double value of x and add it to my value arrays, and then increment it with the step size and check whether or not it's less than or equal to n. So when we go with this step size method, the endpoint might not be included. It depends on the start and the step size. Okay, now here in the simple benchmark, so I call the math utils. Remember, it's a linspace is a static method, so you can just, it's a class method, so you call the class. So let's go from 0 pi. If you recall, pi is in the math class, right? And for the math you don't need to add any imports because it's already in the Java core Java, right? So I'm using that, and the number of points 1 2 3 4 5 6, so 1 million points. And then method 1 is math.sign evaluation, so purely numeric. So what I'm going to do is I'm going to create a timer and import it from my mathlib.util, timer 1, new timer. Okay, and if we head to this timer class, it's a very simple class. So it has 3 fields, and they have package level access, right? And they could also be private. I just set them to package level default access. So they are type long, and when you call the start method, it just calls the system current time in milliseconds. Okay, and then when you when you call the stop method, it calls the system.current time millisecond, and also calculates the elapsed time. The time has passed, so basically subtracts the start time from the end time. When you call the reset method, basically it sets the start, end, and elapsed to 0. Okay, and when you call the show method, it basically just prints out the timer duration plus elapsed time in millisecond. Okay, so if you want to see the result, you can just call the show method. But then I personally prefer to just use, even in my main code, you write the system.out.println. So in order to do that, you have to have a string representation of your object. So that's why I've overridden the toString method from the super class. So this green arrow means I am overriding or implementing a method from a super class, but because it's green, not blue, green means I'm overriding from an object. Basically, I'm overriding a method that is not abstract. So if you go to object, this toString method has already a default implementation. Let's go here to object.class, and it already has a default implementation, so it's not an abstract method. That's why I get that green arrow. If it was a blue arrow, means it's overriding or implementing an abstract method, which can come from an interface or an abstract class. Okay, so green means this has a default implementation, but I'm overriding that. Timer duration elapsed 1 millisecond. Okay, and so basically you create your timer 1.start, and then we do our stuff, do evaluation. I write a for loop for double xval in xvals, basically math.sign of xval. And what I'm doing, I'm using an enhanced for loop, which is also called for each loop. If you're familiar with iterators, this behind the scenes, this enhanced for loop is actually calling the iterators and is implemented based on that. Okay, and then timer 1.stop, and then system.out.println timer 1. All right, let's run this and see what we get. So we're getting about 5 milliseconds. So if you run it multiple times, you see the results might vary a little bit. That's just because the initialization, but you can run it multiple times and take an average. So let's go with method 2, expression evaluation. Now if you remember, note that we need to create the expression of sign of x one time. So let's say string s is sign of x, and then I create an expression x. So how do you do that? So we first have to create an expression builder that calls the tokenizer, and let's do the imports from net.object under x4j. Okay, and pass in our expression or a string, and then call the variables to tell it what parts of this expression are variables. And when you do that, you call the build when you call the build method, it runs the tokenizer and changes this expression into a fully tokenized expression. If you look at what variables method returns, it returns an expression builder. That's why we can do this kind of chaining. So chaining is okay here because it doesn't mutate the original one, it just returns a new one. And then when you run the build method, it returns an expression. Okay, now that we have this expression and it's fully tokenized, we just set the value of the variable. So we again use a enhanced for loop is xvals expression set variable for xval, and then evaluate. Now I'm just evaluating. I don't care about the return type is double, but I don't want to do anything with the return value, so I just evaluate. Okay, now in order to get the timing, I have to create another timer 2 new timer, and then timer 2.start. And when we start, after the evaluation is done, and I can actually put, because I want to compare only the evaluation time, not the time it takes to create the expression. Okay, so I put the timer here and timer to stop, and system.out.println timer 2. Alright, we are all set. Now let's run this. 5 milliseconds for the numerical evaluation for this call to the native method of sign from the math class, and about 200 milliseconds for this. So about a factor of 40 difference. So it's like more than one order of between 1 order to 2 orders of magnitude difference. Okay. Now if we increase the number of evaluation by 1 order of magnitude, the question is, does the time also scale up with 1 order of magnitude? In other words, is the evaluation time or the performance is linear? So for the first time, it went from 5 milliseconds to about 350, so increased 2 orders of magnitude. Here we went from actually I can't remember the number. Let's try it one more time. So 200 to 1600. So it's more like 1 order of magnitude. So it appears that the evaluation time for the sign, the performance of this native call is not linear, but the performance of this expression builder and the evaluation of the expression appears to be linear, because we increased the number of evaluations by 1 order of magnitude, and the time went up by 1 order of magnitude for the expression. Okay. So the last thing I want to talk about is if we head back to the power. So this is basically the end of learning about this expression evaluation library, and as an exercise you can create a simple GUI application in Java and try to implement something like this. You have a variable text box, you set the name of the variable and set its value, and then you define the function based on that variable, and you have a box that evaluates the function at that value and prints it to this box, this result box, when you hit the calculate. When you hit clear, it basically, you can set it up to either clear the results box or all the boxes. It's very easy. Now the options for GUI creation in Java is either the 2 main options that I personally use. It's either Java Swing, and you can use, and it's, I believe it's in the JavaX package, so it's a Java extension library. And option 2 is a newer option, it's Java FX, and you can use an outside application which is called Scene Builder, so it's not inside the Eclipse. So this window builder is basically a plugin in Eclipse. But this Java Scene Builder is a separate app. And the good thing about Java FX is that it allows CSS styling. If you are familiar with if you are not familiar with CSS, it's basically the type of styling that is mostly used in HTML and web styling, and it stands for cascading style sheet. So you can use CSS, and it's very convenient in a lot of sense to do CSS styling instead of trying to do the styling to one object at a time in Java Swing. But Java Swing, in my opinion, has a better integration with Eclipse. It's way more convenient for me, at least, to use window builder in Eclipse. We will try to look at this exercise next time. So thank you for watching this video. I hope you enjoyed it, and please share and subscribe, and I'll see you next time. Hello and welcome to another video on my channel. In this video I'm going to show you how we can use Java and Eclipse to create a simple application, with a graphical interface, to use our expression evaluation library to create to define some function with some variables and just show the results. So we have this is basically a simple drawing of what the GUI is going to look like. So we have a box for setting the name of the variable, we have a box for setting the value of the variable, we have a box for defining the function, and another box that shows the result whenever we hit this button calculate. And there's another button clear, then when we press it, it basically clears all the, well, we can define it such that when we hit clear, it just clears all these 4 boxes. Okay, now as I mentioned before, in Java generally we have 2 options when we are developing graphical interfaces. One is using the Java Swing library, which is in the JavaX or Java extension package. I mean, obviously we have other choices such as AWT, which no one uses anymore, and SWT, Standard Window Toolkit. Okay, but the good thing about Swing is just it's platform independent, but SWT is platform dependent. So if you want to develop a SWT application, you have to use the Java libraries for that specific operating system. But Swing is independent of the operating system. And Eclipse has a very nice plugin for developing Swing or SWT interfaces, which is called Window Builder. Now the second option, which is newer, is JavaFX, and you use another application which is not inside Eclipse, so it's an external application. It's called Scene Builder, and it uses the nice feature of JavaFX is that it supports CSS styling. So if you are familiar with web development and CSS sheets, then it's very easy for you to style all the objects in your interface the way you want them to be. Okay, so a little bit more details about Java Swing. So in Java Swing, the way it works is that you have this window, and it's called a JFrame. So the frame is basically your window, and then there is a content pane, which basically you can define a layout manager for it. So content pane is where you actually put all your content, these labels, these boxes, these buttons in the content pane. Okay, inside the content pane you can have multiple panels, J panels, to have separate functionalities. Okay, now for example in this simple GUI we have these labels which are called JLabel. We have these text boxes. These are where the user can actually put something, write something. These are called the JText field. And then we have these buttons which are called JButton. Okay, now the way it works is that the way basically the user interacts with the GUI, the interface, is that so basically let's say the user presses a button. This triggers an event. Okay, an event is basically something that implements an action interface. So basically in order to handle the user events you have to implement an action interface. Okay, and in order to do that basically you assign action listeners to different items. So you assign an action listener to this button, and this action listener is triggered whenever an event is triggered. Okay, and there are different types of listeners, for example mouse listener, keyboard listener, this kind of stuff. And then you can define multiple functionalities. For example, you can define an action listener and set it to gets activated when some action is performed. Okay, and performing an action is in a simple way is just clicking a button, for example. Okay, so this is how you handle user events, user inputs. Okay, let's go ahead to Eclipse and try to implement this interface. Okay, now if you recall, we had this demo project based on Maven, and so far we have created some classes. So I'm going to create a new class, and it's going to be of type window builder, and I want to create a JFrame, and let's call it simple GUI. Simple GUI. Okay, and hit finish. Let's see what happened here. I think something is wrong with my Java versioning. Let's quickly go to the dependencies. Okay, yes. So the Java version was, I'm going to put this to 8 and update the Maven project so that it knows the Java is it's using Java 8. It previously was set to Java 9. Okay, yeah. So I usually put the interface and the code side by side. So first of all, if you have not installed the Window Builder plugin, go to Eclipse and go to the help Eclipse Marketplace and try to search for Window Builder Pro. Let's see, Window Builder. And I have already installed it. So you install Window Builder, okay, and then if you go to Eclipse Preferences, Window Builder, you can set some preferences. Typically what I do what I prefer to do is in the code generation, I set the method name for new statement. I call it init GUI, so it just initializes GUI, and then the field, the variables, I always prefer to have them as a global field variable instead of local, because when you select local, it just puts all the variables inside the init GUI method. But I prefer to not to do that, have them as a global field, and then choose the actions when defining actions as a block method, okay? And all the field modifiers are private. Alright, so we create this GUI. Obviously it runs the Swing applications on a different thread, and then in the simple GUI it just sets this GUI basically extends the JFrame, so extends the windowing. The default closing operation is exit on close, which basically terminates the JVM, Java Virtual Machine, and the content pane is the top level panel. So basically the frame is the entire window that includes these buttons that come basically from the operating system. And the content pane is basically our top level panel, okay? And it says the borders. Right now the borders are empty borders. These are not that important for us. So what do we want to do? We want to create a panel for user inputs, a panel for showing the results of the calculation, and having some area to have two buttons. So I'm going to create a grid bag layout. This is my favorite layout. It creates a grid. See, it automatically adds them to the code. And then here I'm going to create a JPanel and add it to the top. And for this JPanel, I am going to add border, and I'm going to set it to title border and set the title user inputs. All right, so we have a user input section. And now I'm going to add another JPanel, and again it has a border type of titled border. I'm going to set results. Okay, now we have these two. I am going to add another J panel. In the content pane, another one, and what I'm going to do, I'm going to set the border again, titled border, and here the actions. Let's call them actions. And in the user inputs, what I'm going to do, I'm going to add another grid bag, and then I'm going to add a J label. Okay, let's call it variable, and then I'm going to add a J text field, and then I'm going to add another J label right here. Let's call it value, and then I'm going to add another J text field right after that. Okay, and now I am going to add a J label for function, and as you probably can guess, I'm going to add a text field here for the function that the user defined. Okay, now what I'm going to choose here, I'm going to set it to not grow. Okay, so you automatically resize it. And what I want, so in the actions, again, I'm going to add a grid layout or grid bag layout, add a J button for let's say calculate, and add another J button for clear. Okay, so we have two buttons, and you can resize them the way you want. And if I set it to fill the block, it automatically fills the block. Let's call it to fill. Okay, or maybe make it bigger. We can make it bigger, but then I don't want this part also to grow, so it automatically resizes that. And okay, the only part that I want to grow is this one, and let's see, okay, now I'm going to also delete this row. Okay, alright, so let's save it so far, and let's see what happens. Alright, everything looks great. So as you probably can see, it's super easy. We don't care about, you see the code is very large, but we don't really care about it. This window builder takes care of everything. And let's also add a text field area, J text area. So what I'm going to do here, I'm going to add a J text area to the results, but where did it go? Let's delete it and add a basically J panel to the results, or maybe let's delete it again. A grid bag layout to the results, and then J text area. Okay, and let's see if it grows. Yes. So this is basically our GUI, and let's give these var field meaningful names, and here let's say value field, and then let's call this func field. Okay, and let's call it result field, and let's call it calc button, and let's call this clear button. Okay, all right, so It took us about 10 minutes to create a very nice and beautiful GUI. And now that have this GUI, what we need to do is we need to basically create the logic. So all this GUI, all the code goes into this init GUI block, and then in the constructor of this simple GUI class, it just calls the init GUI block. Okay? Okay. All right, so what do we want to do? So first of all, calculate, clear. So this clear button, if I want to add an action, I want to basically add an event handler. So right click, add event handler, and the type of event is going to be an action, because when the user clicks a button, it basically triggers an action, okay? And it's performing an action. So as you can see, what happens in the code is that in the button, it adds an action listener. As I mentioned, if you want to handle user inputs and monitor what's going on, you have to have some action listener, and it uses an anonymous class. Action listener is an interface, and you have to implement the action performed. And the action performed takes an argument of type action event. So event of type action, okay? Then the action performed for this clear button action performed, what I'm going to do is just saying that var field dot clear just set var field set text to null, to empty string, okay? And value field set text to empty, and func field set text to empty, and result field let's see if it has a clear method. No. So set text to empty. Okay. Now if I run this, now you see that I already ran it, but it doesn't show the window, the GUI, right? So the code is running, and the problem is that in Mac OS, Eclipse by default has in the argument, if you go to the run configurations, in the VM arguments, there is this check mark. Use the -x start on first thread argument when you're launching with SWT. And it also includes the swing, so you have to remove this check and run it again. Now it creates the GUI, okay? Let's see if the action for the clear works. How do we do that? Let's call this x 23 and func x squared. And in the result, let's write something. And what happens if we hit clear? Everything goes away. So the clear works, okay? Now the other thing, next we have to implement the logic for the calculate. Again, hitting this button calculate is basically handling an event, so we add event handler, and it's going to be an action that the user is performing, okay? And what we try to do here is, so we are going to basically, what we are going to do, we are going to get the var string expression. Expression is basically func field get text, okay? And then var name is basically var field get text, okay? And var value is basically value get text, and these are obviously have the type string, so string, okay? Now the next thing we're going to do, we're going to call our expression evaluation library to evaluate this. But if for whatever reason the user the format of the input from the user is not correct, what we need to do, we need to if for whatever reason the expression evaluator cannot handle or cannot evaluate, it always throws an exception. So the best thing to do here is use a try catch, and in the try method double value is a new expression builder, and we pass in our x, and then we set variables are just var name, okay, and then we build it to return an expression, and then we set variable and set the var name to var val, and then evaluate. Okay, so here we have to have a method. We have to have the method evaluate. Okay, but then the problem is that this set variable complains because it says, okay, var name is a string, but var value is a string. And if you recall, we talked about the fact that we have in our math utils, there is a evaluate, and we are going to assume that the user puts in the value box an expression which is numeric. Okay, now the last thing we need to do is basically get this value and show it on the result field. Set text value. Now it's complaining because value is number and it needs a double, so we add \n. So it needs a string, we add \n to set the value, go to the next line. Okay, all right, let's see if this works. All right, so we are here, we are going to put x 2.3 function x to the power of 2 and calculate 5.23, and it goes to the next line. So if I change it, set it again, 12.3, and if you recall, instead of using the parser method from the double class that parse a string to a double value, I use my math util and evaluate. The advantage of that is that I can use things such as pi in nodes. I can use some expressions such as pi over 2. So if you pass this pi over 2 as a string to the parser method, parse double in the double class, it throws an exception because it doesn't know what pi is or how to handle pi over 2, right? It doesn't know how to handle this kind of expression. But the math utils that evaluate, it understands this. Let's say we have some star here. Now let's see what happens. It doesn't do anything because it runs into an exception, but just we can say e2 print stack trace. Now let's see what happens. So x pi sine of x over 2 should give us 1. It does, but let's say pi star. Yeah, it runs into the exception. And we are handle. If we didn't handle it, we didn't use try catch, it just terminates our program. Now the nice thing, you have to always have some sort of information for the user. So you can do something like a J option menu, or you can have something like a J option pane dot error message, for example. You can create a show confirm, show input dialog, show message dialog, for example. Show message dialog, okay? And the upper parent component is this, which is this JFrame window, and error is error in inputs. Okay, now let's see what happens. So we put x, pi, sine of pi over x over 2. We are good. We have pi star. It gives us an error in inputs, an error message. Okay, let's say we fix this, and we put this here again, error in inputs. Calculate sine of x to the power of 2, 1, x4, 0.5, because sine of pi over 4 is 1 over square root of 2, times error. Now you can make it more and more fancier. For example, you can make it that when some error happens in one of these boxes, it automatically detects which box is the error and sets the text to red. Let's see how it works. So for example, let's say we said, okay, I'm going to show a message dialog, but I'm going to, let's say I'm going to assume that the error is in the value. Okay, so I'm going to value field dot set background, for example, and then color dot red. Let's see what happens when we do this. So x, pi, sine of pi over 2, pi over 4, or x over 4, correct, and let's say this, it sets it to red. Okay, now obviously you can see that what happens here is that first of all, the user can edit this number, which is not good. So we want to set this JText area to not being editable. So editable, we remove the tick here, and then we can also disable it. X pi, and sine of x over 4. See, the user cannot interact with this box. This box is just for showing the results. Okay, and we have no inputs. It gives us the error, and yeah, this red box. All right, this was a very simple GUI, but it shows the power of Eclipse and this very nice window builder tool. We basically didn't write any code for the GUI. It creates all these tedious code for us. We just basically gave it the logic, and it's mostly just the actions that the user performs. Okay, now the last thing I want to talk about, just in case you are interested, is the general principles for designing graphical interfaces and applications. And a very famous design approach is called the MVC, Model View Controller, and it's very popular paradigm. And the way it works is that basically your software or your interface has three separate modules. One is the model. Basically this is your objects, your data structures, and the kind of computations you're going to do, right? And then the view is purely your graphical interface, the buttons, what kind of controls to use, buttons, menus, this kind of stuff, what kind of actions are going to be performed. And then the controller is where you define the logic of the GUI, how the actions that the user inputs are related to the changes in the model. Okay, so the controller is what is gluing the model to the view. And in order to prevent your software from crashing, it's always the best practice is to make these as separate as possible from each other. Okay, so they shouldn't directly talk to each other. The other thing is that when you do this, if you want to save the state of your GUI application or software, you just have to save the model, because model is where all the information is, all the objects and the results are. And the next time that you run the software, you can regenerate the view, right? And then only load the model from the saved file into the view. Okay, so you don't need to do anything with the controller. You just have to save the models. That's the core and the information. That's one of the nice benefits of having separate items in terms of module, view, and controller. Alright, this video basically concludes our discussion of the mathematical expression evaluation in Java. And thank you for watching. Please share and subscribe, and I'll see you in the next video.